Hey everybody, this video is going to show you how to convert a logarithm equation to exponential form for the purpose of solving the equation. So these two are inverses of each other, the same way addition cancels out subtraction or multiplication cancels out division. If you have a log equation, you have to convert it to an exponential equation in order to solve it. So in a log equation, you have the base, the thing in the parentheses, which sometimes we don't have parentheses, but you can tell the base is like visually smaller. The argument, the print is larger for the argument, but that's the thing. I put it in parentheses just so you can always tell what it is. But the answer to a log is the exponent of the exponential form. So you can see the base of the log becomes the base of the exponential form. There's whatever the log is supposed to equal, and then the argument is the new answer. All right, so my first example, I'm going to identify that the base of my log is 5. And the part that's actually the exponent on this base is coming from whatever the log was equal to. So in this case, that's 2. If my log equation was supposed to equal 2, 2 is the exponent. And so that's why we do it like this, because now I can just type 5 squared into my calculator and get a numerical answer. So the argument here was x, and in this form, x is now on the other side of the equal sign. So now all I have to do to solve this is do 5 squared. So 5 squared is 25. So to answer this question, x is equal to 25. All right, a question like number 2 is actually a trick question. If you notice, the thing that we're solving for, x, this is already isolated. In the first example, x was attached to the log. So I have to break those two pieces apart. And in order to do that, I have to convert it to exponential form. And this way the x was all by itself. But this is like a trick question. I have the base, but I'm not solving for the argument. So this can be typed into the calculator exactly like that. So if you're using the TI app on your calculator. My calculator. To get a base to show up, it's alpha window, and then option 5. If you've been using the graphing calculator on Desmos to do these, the logs on the graphing calculator, you have to click the little keyboard icon and then click the button that says functions, and then go over to MISC, which stands for miscellaneous, and then you should see a log with a little, I think it's an A, and so you can tell that you can change that number. So again, if you're using Desmos, click the graphing calculator, click the keyboard icon, click the functions button, and go over to the last tab that says miscellaneous, and you'll see it in there. But I just have to type that in. And so the answer is 2. All right, so that one I did not actually have to convert it to exponential because x was already by itself. All right, the next one I am going to have to convert. So my base is x. My exponent will be 5. And this equation has to equal 30. So base, the new exponent, what it's supposed to equal. If you notice, it's kind of following this like circular pattern almost. That usually helps students out a lot. All right, now I'm not going to be able to type x to the 5th power into the calculator and get any type of answer. So keep in mind, this is just a power. So to get rid of a power, we have to do the root. So in a question like this, where you don't know the base, but you have the power, you're going to have to take the root of both sides to get that answer. So in the calculator, If I hit math, change that to a 5. So 1.97. All right, next example. I am going to have to convert it to a log or to exponential because x is inside the log. So my base is 6. My new exponent is 2. And this is going to equal x plus 1. All right, so I'm just going to finish working this out. 6 squared is 36. So 36 is equal to x plus 1. I just have to subtract 1 on both sides. All right, next example. I can't convert this just yet. A log has to be looking exactly like this. There should be nothing in front of the log. There should be no addition or subtraction that's outside of the argument. So if you have anything extra going on, you have to get rid of that first. So in this case, that's this 2. I'm going to want to divide both sides by 2 before I convert it. All right, so now my base is 4. My exponent is 9. And this is going to equal 2 to the power, or 2x. So in my calculator, 4 to the 9th power, it's pretty big. 262,144. And then I just have to finish getting x by itself. So in this case, I'll have to divide by 2. So 131.72. All right, so similar for the next one. I cannot convert this yet because I have this 10 floating around. So the first thing I would need to do is subtract 10 on both sides. Right now I can convert it. My base is 5. My new exponent is 2. And then this has to equal 3x. So 5 squared is 25. Divide by 3. So that's 8.33. 8.3 repeating. All right, so those are all pretty straightforward. There are some special cases with logs. And so these are just ones that you're going to have to remember because sometimes they're like trick questions. All right, so anytime you see just a log and there's no little number down there, that number is a 10. Just like when we write a square root sign, we don't really put the little 2 in the square root symbol. Everyone just kind of knows that that's what it is. So if you see log and you don't see a number for the base, that base is a 10. So to rewrite this and solve it, it'd be 10 to the negative 3 power equals x minus 5. And so we would just do 10 to the negative 3rd power, and then we would have to add 5 to finish getting x by itself. All right, when you see ln, that is sometimes called the natural log. Sometimes it's a lowercase l, so it kind of looks like in, but it's an l, so ln. So the base, when it's ln, is e. So e is that same number that came up in our continuous growth formula with a p times e to the r to the t power. So that's a number, that's a button on your calculator. If you're using Desmos, you can just usually type the letter E. But again, it's not there. You have to know that the base of ln is E. So this would be E to the 4th power equals X. So you would just use the calculator or Desmos to do E to the 4th power and see what that gave you. All right, so another special case for this, you can, you could probably just convert this if you wanted to. There's your base. There's your exponent. It's going to equal X. The problem with this is the domain of a log graph, if you remember the graph of a logarithm, has that vertical asymptote. So it doesn't include any negative numbers. So this can sometimes come up as like a trick question. But with a log, these two components cannot be negative. So the base and argument must be positive. And if it's not, so for this one, my answer to this one would be undefined. And so just be aware that sometimes you might get a trick question, but the base of a log cannot be negative. The argument of the log cannot be negative. All right, hopefully this will help you to do your Delta Math assignment for today. If not, be sure to log into Zoom so that I can help you.